So here we're going to walk through this example, which is to construct a truth table for the statement given here, which is P or Q implies P and Q, or in other words, if P or Q, then P and Q. So remember, this V symbol is the disjunction, which we're thinking of meaning as or, and the symbol we're thinking of meaning and. All right, so first thing we want to do is kind of break this into pieces. So what we have here is basically a big implication or an if-then statement. So this is our hypothesis, this is our conclusion. So what we need to do first is make a column here for our hypothesis. So I've already got the different truth values of P and Q listed out here. So I'm going to make another column with P or Q. So remember, this one is true as long as one of P or Q is true. All right, so its truth table is going to be true in this case because both P and Q are true. If P is true and Q is false, then it's also true. This one is true, this one is false. Okay, and now our next row is going to be the P and Q. All right, and remember, that's only true if P and Q are both true, and it's false otherwise. All right, so those are kind of like our two pieces. And now in our last column over here, we're actually going to write the truth table for the whole implication. All right, so we're thinking about this part as being the hypothesis, this part is the conclusion, and we know that an implication is going to be true basically in all cases except for when the hypothesis is true and the conclusion is false. So again, we're comparing these two columns right here with the implication. So our first one here, if we have true and then true, that makes the implication true. If we have true and then false, that makes the implication false. The third row is the same, it's also false. And then if the hypothesis and conclusion are both false, that makes it true. So here is this last column, I guess I'll put a star by it or something, is our truth table for the statement that we were given. And then we're also asked what other statement is this logically equivalent to. So if you compare it to our truth tables from the beginning of this page, you can see that this is logically equivalent, or in other words, has the same truth values, logically equivalent to the biconditional P if and only if Q.